Hello everyone, welcome to another tutorial on Rstudio. And in this tutorial, I would like to share how to run one-way ANOVA using Rstudio. Okay, as usual, the very first step is to locate the folder that you are going to have your R script saved or your data file being stored. Okay, so always start with setting your working directory. So the first step is go to the three dotted option here, click on it and select the folder that you are going to work on. So my folder is being saved in my pen drive, so I'm going to select on the demo. My folder is called demo, so when I open it, I have it on the F-test. So I'm going to select my F-test. So all the documents, my data file and my R script files are stored in my demo folder under the F-test folder specifically. So if you notice here, okay, on the folder there are .r extension files, .csv, .excel. Okay, so all these are actually my data file as well as my R script file. So once I have selected my folder, I have set it as my working directory. So for that, I have to go to more, click on more and click set as working directory. So if you notice on the console, it appears set WD, set working directory on the G drive demo F-test folder. So now I have already prepared my script. So how do I actually call the script? Okay, so I've already written it. So what you need to do for your assignment or for practices, use the script. This script is already being written, but what you need to do is you have to change the variables or the name that has been used according to your data set and the variable that you are required to include. Okay, so for that, I have my one-way ANOVA.r here under the files. If you go there, it kind of underlines, so click on it. So once we click on it, notice that there is a R script that appears on top of the left hand side. Okay, so there is a window that open it up and it says one-way ANOVA.r. So this is my R script. Okay, so what is my first step? I have to set my working directory. Okay, always remember that the script that I shared, I will have my working directory here. So when you receive it, you have to change this working directory. So how do I change it? Remember, you already set your working directory earlier. If you notice, set G slash demo, right? So this is my new working directory if you see on the bottom. So I have to change this one. For that, I can go to just history. And if you notice, this is my last action that I've done. I've already set my working directory. So what I can do is, I can highlight this and move it to my source. So once I move it now, if you notice, it is already changed. So when you take the script from me and you are reusing it, make sure that you set your working directory properly. Next is you have to activate the library. Okay, you have to select the packages that you want to use. So in this analysis, for one-way analysis, I'm going to use three different packages. Okay, so what are the three packages? They are stats. In order for me to run a t-test, I have a psych to run a descriptive analysis, and I also have car package to test Levine's. Okay, so there are different packages that is required. Third one is I need to import my data file into Rstudio. Okay, now I have my script. I need my data file. Okay, and this data file, what it says here is read a data file called data for one and two way.csv. So what I'm trying to say here is please read this data and call it as data. Okay, here I can change any name. Okay, you can put your own name, you can put one way, you can put whatever it is. Okay, and whenever we use a data set in the subsequent lines, we have to follow this name because Rstudio recognizes this name. Okay, So when I click on it, click run, if you notice there is a there is a blue option. That means it ran successfully. In the environment it also shows. In the history it also shows. So how do we know the data is already being imported? Go to environment. See data. So this data has 48 observation and 3 variables. So if you click on the data option, you see there are day, there is type and inquiry. So there are 3 variables and 48 observations. Okay. So you can close this. We are going back to our script. So what will be the next step? The fourth step is to test assumptions. When we are calculating manually, we do not test for assumptions because we have a small set of data and we assume that it is already meeting all the assumptions. Moreover, when you want to calculate assumption and all, the calculation becomes more tedious and more lengthier. So as I always say, the purpose of learning to calculate ANOVA, one-way ANOVA and all the computation by hand is just to know what is happening behind the scene for this statistical computation. But in reality, you will never do that by hand. So that's why we did not teach you how to run or how to compute normality and other assumptions. But when you're doing it by statistical software, you have to make sure that your data is appropriate to be used for the analysis. So we want to check whether it is appropriate or not. So first thing that you need to check is the normality. Is the distribution normally distributed? So what is the normality that we need to look into? There is only one continuous variable, which is, in this case, is the inquiry. The other variable in this one way will be a categorical variable. So the outcome variable's normality has to be checked. So in this case, it is the inquiry is the dependent variable and the type is the independent variable with 3 categories. So I'm going to test the normality. Okay. Before that, you need to activate all these packages. So click on all these packages. Okay. Now once it is already installed, okay, if you notice that you cannot find the function because we did not activate the package. So make sure that you activate all the packages. Go one by one. Okay. Now let's test the assumptions. Okay, so once you click on the assumption test for normality, descriptive by group. So that is what describe by. So please describe the inquiry variable from the data set called data by the type variable that is stored in the data set. Okay, so on the type, if you notice, let's go back to the data. The type, you have 3 types: news, business and sports. So in this case, what I'm trying to see here is I would like to see the normality of this inquiry variable by these 3 different groups: business, news and sports group. So it gives us the information. So each of these variable has or category has 16 observation, the mean of them, standard deviation of them, and then the most importantly is looking at the skewness. So when we look at the skewness, all of the skewness are within plus minus range of 2. So since they are within the range, so we say that the assumption for normality has been met. Now, next is test of independence. Okay, test of independence, there is no statistical test to examine. But we have to make sure that when you are sampling or when we took the data, one observation in the data is not being influenced by other, meaning one's answers are not influenced by another member. So, but we cannot have a test to assure that. But we assume that when we are taking it, that all these people were responding independently. The third one is homogeneity of variance. So what we are trying to see here is whether the variance across these 3 groups, the variance of inquiry variable, dependent variable, is similar or not across business, news and spots. Okay, so that is what we would like to test it out. So that is what we mean homogeneity. Homogeneity means same. Homogeneity of variance. Okay, so what we are doing is for factor is independent variable type. Okay, so we are running Levene's test. Levene's test. Okay, please run on inquiry by type. But where do we get what anything that is before the $ means it is from that particular data set. Okay, so I call my data file here as data. So please take the inquiry variable from my data file and then examine the variance for each of the three types of groups that is available, that is stored in the data set. Okay, so click on this Levene's test and you will get a result. Okay, so this is the result, Levene's test for homogeneity of variance. So always look at the p-value or the probability value. If the probability value is greater than 0.05, meaning the variances across the groups are similar, are same. Okay, so we always want that. Okay, we prefer that. We do not want to have unequal variances. That means the groups are similar to start with. Okay. Next, we run the analysis, the analysis of variance, the one-way ANOVA. So I label it as, okay, please run inquiry, okay, and then run by factor, the independent factor called type, and get the data. Where do I get this information from? The data called data. Okay. AOV is the function. So Rstudio understands, okay, I need to run an analysis of variance. Okay, so when I run this, okay, it successfully ran. Okay, so it's in blue here. Okay, when you look at it's in blue. So now look at the summary. So when I click on summary, what happens here? So the summary here says that, okay, factor, okay, it tells us degrees of freedom for the factor and also the residual. Residual will be the error, okay, or the within. So degrees of freedom for the factor, for within, sum of squares for both of them, mean square, f value and the p value. Okay, what is this p value? This p value is the probability value associated with the f value. So with this p, this probability value or the p value, we compare it to our alpha, which is 0.05. Since our probability value here is greater than 0.05, meaning there is no significant difference between the three groups on the inquiry. Okay. So once you have not significant, you stop the analysis here. Okay, you stop your ANOVA here. But in case if this probability value is significant, okay, based on this probability is less than 0.05, then you need to run a post hoc analysis. So what you do here is 2 keys HSD, okay, one way. Where do you get this one way? From here. We run the analysis just now, right? So we are going to use that here. So run a 2 key HSD. Okay, it ran successfully, and then now let's look at the results. What does the result say? Okay, so it fit an analysis of variance, this model, okay, as a factor this type. So these news, business, sports news are 3 different possible combinations that we can get. Okay, because there are 3 groups. So we have news, business and sports. So what are the possible pairs that you can get? News and business, sports and business, sports and news. So you have 3 different groups. And then look at the P adjusted. So all these P adjusted showing that it is greater than 0.05. If it is less than 0.05, then there is a significant difference. But here all of them are greater than 0.05, meaning all these pairs are similar. Their means are not different. Okay, which makes sense because initially when we ran one-way ANOVA, here it shows there is no difference. So basically when you look into further, it still shows there is no difference. Okay, so I hope it was clear. Thank you very much.